Hi everybody and welcome to Getting Started with Android Development. I'm Gary Simmons, and in this workshop I'm going to be showing you how to build games for mobile devices using the Unity game engine. But that's not all. I'm also going to show you how you can take your finished game and make it available to the masses. That is, I'm going to demonstrate how you can publish your game to mobile app stores such as Google Play Store and the Amazon App Store. Now, as game developers, we can no longer ignore the mobile app explosion. The Google Play Store alone now has way over 1 million apps available, and other app stores like Amazon are also becoming big players in the field. In December 2013 alone, just 1 month, over $1 billion was spent by Apple customers in the Apple App Store. This equated to a download of almost 3 billion apps. Furthermore, the majority of top publishers in all three app stores were game developers. In this sub-series of videos particularly, I'm going to be demonstrating building and publishing games targeted at smartphones and tablets running the Android operating system. Now, I'm not going to be writing a new mobile application from scratch. What I'm going to do instead is I'm going to port the game Balls of Steel, which is the breakout game that we developed in the Intro to Unity workshop. This video is not going to be an in-depth discussion of all the various best practices when developing mobile applications in Unity. Instead, it is going to be a guide to show you how to set up Unity and your development environment for Android publishing, and how to alter or write new application input routines to cater for the input mechanisms on these newer mobile devices. And finally, like I said, I'm going to show you how to publish your application to the Android markets. Now, if you have not yet gone through our Introduction to Unity workshop, I would definitely do that first. This lesson will not discuss a game, how the game was built, or how it works. It also won't be an introduction to Unity or an introduction to C# scripting. Furthermore, you really need to have an Android device available for testing. The SDK, that is the Android SDK that we'll be installing later, does ship with a software emulator tool, but it's so painfully slow at running Unity apps as to be almost useless in my humble opinion. But hey, if you want to see how you get on with it, that's fine. Now, in order to make these videos as complete as possible and show you the entire pipeline from building the app right up to bringing it to market, I have published the mobile version of Balls of Steel to both the Google Play Store and the Amazon App Store. Here on the screen right now you can see a screen capture of my own mobile phone and me searching the Google Play Store and finding our game, Balls of Steel. Hey, there it is. Balls of Steel is available both on Google Play and on Amazon's App Store, so that Android powered devices can search for our game and install it with just a single click. Now, obviously the Balls of Steel game was a very simple demonstration just to get you used to scripting in Unity. It doesn't have any levels, it doesn't have any social features such as leaderboards or achievements, so I'm not really expecting it to get much interest from the wider public or a load of 5-star reviews, to say the least. It's there so that you guys can see the final result of this lesson, really, of how we were able to bring it to market and publish our game to the public. But if you have your Android device handy, then why not pop onto Google Play or the Amazon App Store and take it for a spin. Also, it would be pretty nice to have another 5-star review from somebody that isn't just my mother. Oh, and by the way, another important point, and I found this out myself the hard way: when you publish your app, if you give your own app a 5-star review, it's not anonymous, okay? And take it from me, that's pretty embarrassing. Over time, we will more than likely release further videos in this series that will drill down on more specific mobile development topics, such as how to avail ourselves of cloud services such as Google Play Game Services, Google's in-app billing, and Amazon's Game Circle, all of which provide not only in-app billing but also multi-platform leaderboards and achievements stored in the cloud. For now though, we're going to concentrate on creating a free application and how to bring that application to market. So you've already decided that you want to make a mobile game. But what are you going to use to do this? What programming language? What IDE? Are you going to use any middleware such as Unity? And if so, what makes Unity the right tool to develop mobile games? Well, we already know that Unity is an insanely popular game development middleware, with over 400,000 monthly active developers and 2 million registered developers in total. Unity already claims such customers as Microsoft, NASA, the Cartoon Network, Coca-Cola, Electronic Arts and Warner Brothers, to name but a few. But it is in the mobile ecosystem that Unity really dominates. It is by far the world's most popular game development middleware, so using Unity for our mobile games puts us in very good company indeed. To get some context, in August 2013 it was discovered that 100 Unity-powered mobile applications were being installed every single second. This equates to 10 million Unity-powered mobile installs per day. And that only accounts for applications that opt in to statistics gathering. Unity Technologies estimates the number could have been as high as 20 million installs per day, and in general over 10% of all mobile app installs. So we now understand that Unity is clearly up to the task of being the technology behind our mobile creation, but there is an even more compelling reason to use it since May 2013. For it was then that Unity Technologies announced free mobile publishing. To explain, up until that point, the Android and iOS build platforms had to be purchased as add-ons to Unity. And furthermore, 2 extra licenses existed for each. There was a basic version and a pro version for these add-ons. They were originally priced at $750 and $1,500 respectively. Just like Unity itself, the Pro version and the basic version of, for example, the Android add-on would differ in the features that they support. Now you can visit unity3d.com and view the feature comparison lists of each platform. In May 2013, however, Unity Technologies announced that the basic version of their Android and iOS add-ons would now be completely free of charge, not just for customers that have purchased Unity Pro, but for those using the free version of Unity also. This meant that for the first time, indie developers could create Android and iOS platformed games and publish them to the market spaces without spending a dime on development tools. It should be noted, however, that if you wish to purchase, for example, the Android Pro add-on, you would first have to upgrade your Unity license to Pro also, and the same applies to the iOS add-on. So if you wanted to develop for the Android and iOS app markets and wanted, for example, to have post-processing effects or deferred rendering capability, the total cost to you would be, as of the 9th of January 2014, $1,500 for Unity Pro license itself, and then an additional $1,500 for each add-on. So a total development environment cost of $4,500. If you intend to develop for Windows Phone 8 or Windows Store 8, these come completely free, built into Unity Pro only. Okay, that's important. They're only included in the Pro version. So we have discovered already that Unity is definitely a very valid choice of middleware to use for the development of our mobile game. But then the question comes up, which market should you target first, iOS or Android? Now that has been the topic of much debate over the previous years, and to be honest, iOS normally comes out on top, but that landscape is changing daily with the rapid growth of Android. So let's investigate that argument ourselves in the next section. Historically, publishing an Apple app was always seen as the first and highest priority, despite the fact that publishing to the Apple App Store has always been a complete nightmare, well, in my opinion, and this outlook was understandable. By the second quarter of 2009, Android had only a measly 2.8% of smartphone market share. By the fourth quarter of 2010, however, that had ballooned to 33%, placing it as the world's top-selling mobile platform. The growth continued, and by the third quarter of 2011, that share had grown to 52.5%, and as of the third quarter of 2012, 75% of the smartphone market belonged to Android. It was estimated in May 2013 that 48 billion apps had been installed from the Google Play Store, and by September 2013, 1 billion Android devices had been activated, and its growth and popularity continues still. As of November 2013, Android's share of the global smartphone market, led by Samsung products, has reached 80%. So this certainly changes the view of Android, at least by some developers, as a second-class citizen. Also, publishing to the Android app stores such as the Google Play Store is a lot more nurturing to developers and to new application development. You can digitally sign your app inside the Unity build process and just build the APK file. At that point, you can email it to somebody, host it on a website, or upload it to the Google Play Store or the Amazon App Store and have it available worldwide in just a couple of hours. The Google Play Store is ideal for releasing your first app. If some of your users encounter a problem, you can simply solve, rebuild, upload, and have that fix in place within an hour or two. This makes it an ideal ecosystem to improve your app quickly in line with customer feedback. Android publication could not be simpler. You get statistics and crash reports, and you can upload a bug-fixed version immediately. Publishing an Apple app, on the other hand, is a pretty frustrating affair. Apple's iTunes Connect website is not that nice compared to Google Play's developer console, and it's hard to get any crash reports at all, much less ones that have any useful information in them. Furthermore, and perhaps more importantly, it can take a week or more to get your app published after you've submitted it for approval, and even then you may have to jump through several hoops to make it comply to their demands. And if it fails approval, or if a bug is spotted and needs a fix once it goes live, resubmission can take another week or more. That's pretty bad. So from a publishing perspective alone, I think this makes Android a clear winner for somebody just starting out with their first mobile game in Unity, as it will allow them to hone the game mechanics and the game's features quickly and easily in response to customer feedback before porting it to iOS. However, if you're making a game to sell instead of a free game, then we also have the financials to consider. Now, it has long been known that the Apple App Store is a more lucrative market despite the disparity in platform market share and the number of app downloads. Although Google Play's revenue share has been rapidly growing at Apple's expense, the Apple App Store is still leading quite strongly in this area with 63% of revenue share. This leads to the conclusion that Apple customers are either wealthier or just more willing to part with their hard-earned cash and actually pay for apps more readily than Android users. So this once again makes the Apple App Store a more attractive proposition for your game, and indeed this is why many developers choose to target it first. But the Apple App Store is now extremely hard for new apps to get noticed in. Unless you have a significant advertising budget, your app will most likely get lost immediately in the market clutter. Not a single app released in the Apple App Store in 2013 managed to make it into its top 10 apps list. On the Google Play Store, on the other hand, 4 of the apps released in 2013 did successfully make it into its top 10. So Android is going to be my target of choice for this presentation. So let us talk a little bit for a moment about what Android actually is, as some of you may not be too familiar with this operating system. The Android operating system is based on a Linux kernel and has been designed primarily for touchscreen mobile devices such as smartphones and tablets. In 2005, it was purchased from Android Inc. by Google, who had been financially backing it, and the first version was released in 2007. Much like iOS, Android is an operating system optimized for low memory footprint and built to support input devices and a user interface based on direct manipulation. That is, using real-world actions such as swiping, dragging, tapping, and pinching. Internal hardware exists in these devices, such as accelerometers, gyroscopes, and proximity sensors, which can be used not only by the operating system, but also by third-party applications to respond to user actions. As game developers, we're definitely going to want to utilize these new input mechanisms to make our games more appealing to the mobile user. And fortunately, Unity's Input Manager provides us with easy access to reading many of these input devices. We could easily have a car game, for example, where tilting the device physically from left to right controls the steering wheel, or have our application track multiple finger touches on the screen for RTS unit assignment. So, what actually is an Android application? Well, Android applications are packaged into APK files, short for Android Package Files, and stored by the operating system in the data/apps folder. It is these Android package files that Unity will compile for us, and will be the ultimate result of an Android build process taking part in Unity. It is this final package file which will then be uploaded to the Android markets such as Google Play or Amazon's App Store. The package file contains many things. Of course, it contains all the resources that are used by our application, but it also contains the bytecode of our application stored in DEX files, and that's short for Dalvik executable files, but more on that in a moment. To understand the format of our code in these DEX files, we need to talk a little bit about software development on the Android platform when third-party middleware such as Unity is not being used to aid us. Just as the primary development language on iOS is Objective-C, the primary development language on Android is Java. Applications are usually written in the Java language and compiled using the Android Software Development Kit, which is freely available from developer.android.com. Much like the standard Java runtime environment, software called a virtual machine is used to run apps on the Android devices in a secure environment. However, the virtual machine on the Android platform is not the standard Java virtual machine used by the Java runtime environment. In fact, while most Android applications have their source code written in the Java language, there are many differences between the Java API and the Android API. Android does not use the Java virtual machine at all, but instead uses another one called the Dalvik virtual machine, which was specifically developed for the Android platform. The Dalvik Virtual Machine, or DVM, has been designed to run on devices that are very limited both in terms of memory and processing power. It has been slimmed down to use less space, and according to Google, multiple instances of the Dalvik Virtual Machine can be run very efficiently, and that's very important on the Android platform, as every app that you run on your Android device will run in its own Dalvik Virtual Machine instance. In a standard Java development environment, the Java source code that you write is compiled, usually from within your IDE, into a type of intermediate code called bytecode and stored in Java class files. Now at runtime, these Java class files are loaded into the Java virtual machine and are just in time compiled into the machine code for the native architecture. It is this virtual machine and the deferred compilation that allows the source code that we write in these languages to be written in a architecture independent way. Now when developing for Android, the situation is a little bit different. The Java bytecode generated by the first phase compile is not directly executable by the Dalvik virtual machine. Instead, the Java class files are then compiled into DEX files, Dalvik executable files, by a tool that's included in the SDK called DEX. Now the DEX files are then stored in the package file along with the application's resources and are then ready to be run by the Dalvik VM. Furthermore, since Android version 2.2, the Dalvik virtual machine also has a just-in-time compiler, making it run much more efficiently. The Dalvik executables may also be modified again when they're installed onto the mobile device in order to further optimize the platform on which it is to be executed. Now the Android SDK includes many development tools to aid developers in writing and compiling their source code into Android package files. The SDK includes the Android libraries themselves, of course, allowing your source code access to the Android API, as well as a debugger, and a software emulator allowing you to test your application on a variety of smartphone and tablet configurations that you may not own yourself. It also ships with documentation, code samples, tutorials on getting started, and many other tools as well. Furthermore, the Android SDK supports development on a variety of platforms including Mac OS X 10.5.8 or later, Windows XP or later, and Linux. Now, tools, add-ons and plugins are also available now that allow developers to develop in a variety of languages, not just Java, things such as C, C++ or even BASIC. Now, with regards to writing the source code, developers can use any text editor they choose to author their Java source files and their XML source files. And they can use the command line tools in the SDK to create, build and debug their applications. But many developers, like myself, would much rather use an IDE, an integrated development environment, for this task. Several third-party IDEs can be used. The NetBeans IDE supports Android development via a plugin, while the IntelliJ IDEA IDE supports Android development right out of the box. The officially supported IDE, however, is one called Eclipse, which supports Android development using the freely available ADT plugin, short for Android Development Tools. Now, this is probably all starting to sound terribly complicated, isn't it? But don't worry. If you visit developer.android.com, you can now download what they call their ADT bundle for your chosen platform. This includes not only the complete Android SDK, but also the Eclipse IDE and the ADT plugin for Eclipse, allowing you to install everything you need from a single archive file. Now, we're going to go through all the steps of downloading and installing this bundle shortly, but you might be thinking, hey, why are you telling me this? Why do I need any of this? I'm using Unity. Well, the reason you need to know about this is because Unity will need access to the Android SDK. It will need it to be installed on your system because it needs to utilize the Android SDK tools to build the final Android package. So finally, let's just finish up by talking a little bit about the various versions of the Android system that have been released, because you're going to come up against this quite a lot when you're developing and you have to target for a specific version. So as developers, we need to be aware that since its release, Android has seen numerous updates which have not only improved the operating system by adding new features, etc., but have also kept it up to date with the power increase and the new facilities that's available in the newer mobile tech. Now, each major Android release is named in alphabetical order after a kind of after dinner dessert, if you like. For example, version 1.5 was called Cupcake. This was followed by 1.6 called Donut, and that was followed by version 2.0 called Eclair. Now, the latest version at the time that this video was recorded is version 4.4.2, and they've named that KitKat, and that was released on the 9th of December 2013. Furthermore, not all operating system versions can be accommodated by all Android smartphones and tablets. Now, in these examples, you'll see me using my Samsung Galaxy S2 phone, and that came installed when I got it with Android version 2.3 named Gingerbread. Later versions of this exact phone shipped with Android version 4.0.2 named Ice Cream Sandwich. In the case of my phone, it can still be upgraded, I believe, to support the latest operating system, KitKat. But not all phones are created equal, and there will still be thousands or even millions of Android phones out there in daily use that either do not have the latest version of the operating system installed, or literally don't have the hardware requirements to be upgraded to it anyway. As of November 2013 and version 4.4, Android requires at least 512 MB of RAM and an ARM v7 processor. OpenGL ES 2.0 hardware acceleration is also mandatory, and OpenGL ES 3.0 is also supported. Now, at the time of recording, the operating system version 2.x Gingerbread, the one I'm going to be using on my phone here, is still in pretty widespread use. That means we as developers will need to make sure that in order to keep our market as large as possible, that we target the lowest OS version that is feasible for our game and its demands. Of course, there is nothing stopping us from building multiple versions of an application targeted at different OS versions so that we can scale an application's features down for earlier devices while still offering a version that benefits the hardware features available in the newer devices. When we build an Android application using Unity, an XML file called a manifest will be contained within the package file itself. And this is read by markets such as the Google Play Store when we upload our application so that it can ascertain the minimum operating system and hardware requirements. If we target the very latest operating system, Google Play will only display our game to those with that operating system or above installed on their device. They'll be the only ones that can see and play it. In this lesson, I'm going to be targeting 2.x Gingerbread as our base operating system, which I think is also referred to as API level 10. And that's going to make it available to a vast number of phones and tablets, but it's still a kind of recent enough platform that it's going to filter out many of those really early devices that just don't have enough raw horsepower to run our Unity app in all its 3D glory. The Google Play Store will also identify the hardware that our app requires and will not offer it to users on devices that cannot support it. For example, if we chose to use the accelerometer in our game to control the paddle in Balls of Steel, this would be detected and Balls of Steel would only be offered to shoppers that have accelerator capability in their device. So let's just see a brief overview of the steps that we're going to have to take in order to take our Balls of Steel game and publish it to the Android market. We've already stated that in order to build Android packages in Unity, we must have the Android SDK installed, but that's not all. The Android SDK needs the Java development kit to be installed also. Now, many of you will already have the Java runtime environment on your computer, but this isn't the same thing. So on the screen now I'm going to show you the steps that we need to take and the order in which we need to execute them, and that's what we're going to be covering over this series of videos. Please note that in this video I will be showing examples of setting up everything on a Windows operating system, so if you're developing on Mac OS X or Linux, please be sure to download the appropriate versions of the software and tools for your platform. So the first thing that we're going to do if we wish to test our game on our actual Android device is we're going to have to install some USB drivers for that device for our development platform. So for me, I'm going to have to install the Windows USB drivers for the Samsung Galaxy S2. We're then going to have to visit Oracle's website, download and install the Java Development Kit. Then we're going to go to developerandroid.com and install their ADT bundle. Next, we're going to run the Android SDK's package manager so that we can add support for the operating system that we wish to target, which in our case is going to be the 2.x Gingerbread platform. Then we're going to configure the actual mobile device for connection to our development computer and connect it via a USB cable. We will then configure Unity to know all about the location of the Android SDK and switch and configure the build settings to build an Android package. We will then compile and test our game on our mobile device, and then we're going to have to rewrite the input routines of our game to use the input mechanisms available on that device. And finally, you're going to see me publish our game to the Google Play Store and the Amazon App Store. So that's the end of this overview video. In the next video, we're going to start making our way through that list of tasks.